Our screen now?
Yep,
Yes.
you're a presenter.
All right, perfect.
Well, thank you so much for inviting us today to talk with you. My name's David Brannon. I'm president of the National Oceans Applications Research Center, NOARC, here in Mississippi, and I have with me two of my most important strategic partners, Joel Lawhead and Natalie Guess from Envisions LLC, our data compilation experts. Just by way of introduction, NOARC was created in 2013 by our governor, and we were chartered by the governor to not only bring new environmental monitoring technologies to our restoration work following the BP oil spill, but to use those new technologies and new applications as a platform for developing new jobs and new opportunities for our kids. And so the agenda that we have is supported by our core team. And I wanted to point out that one of our favorite core team members is out of Stuart, Florida, Sea Robotics, and they're the ones we partnered with to develop and re-engineer one of the craft that you're going to be seeing here in a moment. So I wanted to point those folks out to you. We're really happy to have them on board. Just to introduce briefly our research agenda. Now it's an applications research agenda, which means we're really developing new technologies, testing new technologies, and bringing them to bear on our restoration objectives. You see number one on our list here is oyster restoration. Now, I was having some interesting flashbacks with Tony's presentation, because we used to support a lot of that kind of work, Tony, until the Bonnie Carey spillway put 98% of our oysters in the tank. And so now we're trying to rebuild what we hope will be an oyster fishery. But at the very least, we want to build enough reef so that we improve our water quality, which all of you are working hard and have been for decades. And so the work that we're focused on really has three key parts. Nearshore benthic habitats, oysters, seagrasses, hard substrate for doing a lot of different things. We're looking at net gain and loss of wetlands and coastal uplands with an airborne solution that we can talk about some other time. We'll show you some examples of that. And then what we call working waterfronts, which is a derivative of what we're doing in the nearshore benthic habitat work, and it helps our navigation security and port authorities here on the Mississippi Gulf Coast. Now, after much searching and proof of concept testing, we arrived at the Surveyor 1.8 from Sea Robotics in Stuart, Florida, and it satisfies a challenge for us, which is to be able to acquire detailed bathymetry and detailed side scan sonar in shallow water environments. When we say shallow water, we're working consistently in 2.5 to 3 feet of water with this craft. We have some data that we collected Tuesday that we want to show you. And so this is our workhorse for shallow water environments. We have some other options to do deeper water, cover more ground, but this is our workhorse for now in near shore. That's its maiden voyage in a local marina. These are some areas I want to touch on that are our test sites that we're monitoring both near term and long term as indicators for how well we're doing in Mississippi with oysters. Our flagship project is an area here in the Bay of St. Louis. It's a sanctuary reef sponsored by the Nature Conservancy and National Fish and Wildlife Foundation, and we've come on board to help them with monitoring and mapping. NIFWF had a very simple question to TNC is, we would like to participate in this project with you some more, but how do you know it's still there? And so being able to answer that, how do you know it's still there, was a fundamental question that we were able to answer for TNC. The reason they were a little bit concerned is that this is the existing bathymetry data that we had in Mississippi that they were trying to use, and it's hardly possible to see the oyster reef features at this scale. And this is an image that we acquired. Gives us an up close and personal view of the reef. You can see it there highlighted in the lighter areas. Remember, we're getting both bathymetry and side scan sonar from the EdgeTech system. This yet another view of the raw data from the side scan over same area. This is a composite, which is our favorite product and the one that helped NIFWIF and TNC understand the application that we were developing and testing. Is not only can you see the outline and the structure of the hard substrate at a decent resolution, you can see the bathymetry over the reef. And this picture, this image right here, has multiple uses clearly, but one of the more important ones for us is to be able to compute volume over that reef and how that volume changes over time, because we now with this system and the right GPS system built into our little UAV, we're able to image the same area the same way every time. This is an image, we're proud of this image for a lot of reasons. It's a raw data set, came to us this morning. We acquired it Tuesday over the same site in Bay St. Louis. And what it represents is the old reef, which is the northern part of, if you bisect that image, that's the older part of the reef in the northern part of the image. And then the bottom part here, the curlicue image, is a Gulch application right before Labor Day 2020, where our Secretary of State was involved in, and he even showed us the areas that he applied the oyster shell. And so we wanted to give them wanted to create a composite of the old and the new. And the same point applies, that when we use the maximum resolution to show you, which is right here, remember, this is just a raw data set, but you can really see the relief on the reef. See the shadows there on the northern side of the image on the left. We're getting some really good returns off the reef, and it's very, off of the recent Gulch area. And so that gives them confidence that we can monitor and we can measure the reef, monitor it over time, and make sure that the reef is not only progressing, but with in situ measurements or in situ collection of oysters, we know exactly the health and vitality, which you guys talked at length about a moment ago. Now this is another example close to Biloxi Bay. This is different Gulch application that we monitored the day after they put the Gulch in the water. This is a different application technique. They anchored around one point and circled it, and you can begin to see the pattern as we move in closer. Excellent. That's the high frequency side scan, and as Joel comments, usually it looks like a crop circle, but it's just a different Gulch application that they wanted to try. And remember, we're in the process of rebuilding an oyster fishery, because ours was almost completely demolished after the recent Bonnie Carey spillway release. And so we're experimenting with different Gulch applications to see which ones are the most effective and produce the most reef stability and more oysters. This little area was important for us over just east of the one I just showed you. This is off the beach in Ocean Springs, Mississippi. It's an old reef, and it's been there for the boat captains for decades. Have been collecting oysters off this reef until silt covered them up. You see the two brighter areas there under about 8 inches of silt, but it's when you dig down, there's old oyster shell there. So we were excited about a little bit of surface penetration with our system, but it also gives us the ability to image nearby an existing oyster reef to see if there's still more substrate that we could rebuild, and the substrate would hold the Gulch application and not sink out of sight. So this was an exciting piece of data for us. I wanted to mention that everything that we do here that NOARC does is built into a NOARC Tidelands Atlas in Mississippi that's for multiple agencies to use. we extended 7.5 minute quads, quarter quads into the sheets. And we're using a 100-meter grid, map grid to reference all of our work so that we know exactly where we are at all times and we can monitor change within those grid cells. And so I just wanted to point that out to you. That's how we're doing it. Now we're going to show off just a little bit. This is a video of actually one drone's taking a picture of another UAV, which is overflying the little boat out on an area that we Mississippi have reconstructed on Round Island. Now, just for a moment, let me tell you why this is important to us and potentially important to you. One of the challenges that we were given was to be able to provide three-dimensional terrain analysis of reconstructed barrier islands, which you're about to see a picture of. And in order to do that, we need to be able to do precision offshore bathymetry and side scan so we can do a precision near shore three-dimensional terrain analysis and then have a seamless transition to onshore. That little bird is flying a photogrammetric camera with a LiDAR system. And we're today, the same team that you saw standing over there on the beach is flying Round Island with the LiDAR that we have landed on for our continued work. It's a beautiful little system, 20-something-year-old that created it out of Northern California. And it weighs about 3.5 pounds and gives us more points in our point cloud than anything that we've seen. Just to digress for just a moment, we started out with the same LiDAR that Elon Musk puts on Teslas. Works great in ranging distance, just exactly what it was supposed to do, but it was really almost impossible to relate to a map base. So we went to another one, and we have found this one that we'll be glad to show you later. But it provides a point cloud that is ridiculously precise, and we're excited about that. It's just an oblique image of the area there in Round Island. You see on the right side the section that has been recreated and built up and dredged up. And over time, we're going to be doing a lot of work in this area, not only to add to this island, but living shorelines are in the queue, along with oyster reefs developed in the area to act as a living shoreline, which you guys have way more experience with than we do. We could use your help. But that's why the three-dimensional analysis from just offshore to onshore is so important, so that we can assess and monitor the viability and the sustainability of the work that we're doing in restoration. We can answer those kind of hard questions. How do you know it's still there, and how do you know it's working? So we can answer that. That's just another view. You can see sort of the view of the tent and the landing pad for our aircraft. I wanted to show you this. Looks like a basic aerial image, and it's fairly basic, but that's a digital image taken at less than 2 centimeter resolution, about a square inch of resolution, and it's we can map and monitor about any land cover that we need to map and monitor. If we need something on a broader scale than this, we use satellite imagery or a higher flight of our unmanned airborne system. Next, in 2 weeks, we'll test my favorite instrument, because we have created this 5-channel multispectral instrument that will require imagery at about 2 centimeters so that we can have a composite LiDAR point cloud overlaid with land cover, and that was the ultimate system for doing this restoration monitoring and analysis. You can see the tire treads of the caterpillars that were pushing sand around out there to build the island. If we really were going to show off, we'd show you some of the bird tracks over here on the beach, but we'll do that some other time. Just a summary chart. We've worked our little boat off of service boats and others. We have some that being designed for us right now that allow us to take our little boat. Take our little boat into shallower water as a mothership. And we're excited about that, and it'll be optionally piloted. autonomous operation as well. So let's see, one more chart. There's the character you can contact if you have any further questions. I know you'll have the presentation online. We'd really enjoy discussing what we're doing with you later and see if there's some common benefit to what we're doing. And I'm sure there is, because you're about 20 years ahead of us. And so maybe we have something to offer in high resolution monitoring and analysis. So with that, I'd love to answer some questions. And if I can't answer them, Joel can.
Thank you, David, and everyone for putting that together. That was really interesting. You know, being a Southern Miss graduate myself, this makes me very proud of the region.
Very nice.
I think we have a couple of questions from members. How about Sandra Brooke?
So let me unmute myself. That was really cool. I love mapping. How do we use your services? Is this through a research relationship or a contractual? And how do we go about that?
Now that's a question we get quite often, and the answer to that, I swear I'm not trying to be facetious, is all of the above. It depends on you.
Okay.
One of the things I blew by very quickly was, having worked with NASA for a whole lot of years. By the way, I enjoyed seeing your water management districts on the earlier chart, because I worked with all 5 of them for about 7 or 8 years in Florida. There's not much of Florida I haven't mapped. My friend Ken Haydad. But the reason I mentioned that is that some of the lessons that I learned from the NASA experience, I've been able, by the grace of God and the governor of Mississippi, to put them into practice in this 501c3 private nonprofit organization, which means that we can work a research project with you just with a memorandum of agreement, and we have a collaborative application research agreement, which frankly is what we do most all of our work under. But it's a very flexible contractual arrangement. A bunch of boilerplate up front, and then we attach task orders and work statements to it, depending on what each one of the partners is doing.
Okay.
And so we can. Our challenge in the near term would be deployment. The actual monitoring and work, amazingly enough, even though it took a lot to develop it, it's pretty simply applied. But it's the logistics that go along with moving it all to you or to some site that we would have to negotiate and cover expenses for. But we would dearly love to. I don't know about my 2 partners here. I would dearly love to get back to Florida and do some more. I miss it.
Well, we're in the Panhandle, so it's we're not Miami, so it's a little bit
short
more
drive
straightforward. But
now, I spent a lot of my misspent youth in the Florida Panhandle.
it sounds like a conversation for another time. So do I get in touch with you or with your president to discuss this?
Well, that would be both of us. That's me right there on the screen.
Oh, that is you. Okay, sorry.
Well, it's all right. We'll go from there.
Yeah. Okay.
We
Thank you
can
so much.
provide proposal language because this is still considered a kind of a different approach using drones in a lot of cases. So yeah, we've done it both ways, where we provided help write the proposal for a grant or just straight up contract us and we show up and
yeah, it's actually we're actually using drones at the moment, so I'd love to get into another conversation with you about logistics and the details of that. But what I'm specifically interested in is the subtitle stuff.
Yes.
So okay, thank you very much. To be continued.
Thank you.
This is Corey with Florida Fish and Wildlife again. Just curious, David, you mentioned that a common operating depth for the AUV sonar vehicle was about 2.5 feet. What's your minimum operating depth on that, or minimum depth that you can get reasonable sonar readings?
we can get reasonable readings at 2 feet. Anything less than that, it's a little counterproductive.
So yeah, so the approach there, I mean, the hydrographic community typically considers shallow water less than 300 feet. So we're referring to this as ultra shallow water. So the drone has, first of all, it's an interferometric sonar. So that gives you almost to the water line as far as your beam angle. And then it's also mounted in the hull. So it's not a pole down the water. There's also no humans on it weighing it down. So it gets us as far away from the bottom as we can in any situation. So yeah, we've been able to get a good map at around 2 feet. It works great at 3 to 6. And yeah, 2 feet, that's a lot of lines you got to run to collect these, and the beam does get pretty narrow at that point. But yeah, it's definitely made for this kind of habitat.
Plus, I threatened my technicians if they got it in less than 2 feet of water. We won't tear up my little boat.
And so getting that space.
By the way,
between...
let me add something to that for just a moment.
Mm-hmm.
If we consistently needed to map incredibly shallow subtidal or intertidal, mapping intertidal oysters with our current LiDAR would be a breeze. I can say that without any qualification. So if you had some decently clear water, anything from 2 feet to the shore, we could map from overhead. But if it gets its feet out of the water at any point in time, we map it with our LiDAR instrument.
That was my follow-up question, how you would go about stitching together either that small range between the 2 feet and the low tide line, or, wait until you can get some penetration with the aerial stuff. So that you anticipated my question. Thank you.
That's it exactly.
We could also, when there's water surface, it's a little more work, but we're using a lot of, not just the LiDAR, but the structure and motion from the cameras is getting pretty incredible as far as the positional accuracy. And so there's some things we could do with that. So we usually end up with 3 point clouds if we're flying everything at once. With the bottom from the sonar, that drone actually has a LiDAR on top of it as well. So we get a point cloud from that, and then what we get from the drone. So up to 4 point clouds in some cases. So it gives us a good bit of data to sort of piece in those gaps.
Wow. Okay. Nice. Overlapping techniques there.
Yeah, it's even easier where you guys are because our water's all brown. So Florida's so much nicer with the pretty blue water, especially along the Emerald Coast there. And yeah, it actually gets even better results.
Yeah, we couldn't leave to be down there in your area before about noon.
Very good. Very good. Steve Durham, you'd like to ask a question?
Yeah, hi, thanks for your presentation. I'm having some connectivity issues today, so I apologize if you've already answered this question, but I'm curious about the ability of your surface autonomous vehicle to do sub-bottom profiling with the sonar. Do you have frequencies that can penetrate the sediments?
So we can get through, I think, about 6 inches as it stands. We've got a partner that has a small drone-sized sub-bottom profiler, but we haven't experimented with that a lot yet. But that's definitely on our mind. We're looking for an opportunity to work with that. We've got a plan, but we have not really tested it yet. But yeah, the edge tech will get us about 6 inches of silt, give or take.
Okay.
That is low.
All right, thank you.
That's low frequency if there's something hard underneath, especially, that we can bounce off of.
Yeah, the best example we have of that is that image, brown image off Ocean Springs, where we were able.
Yeah, that's an example of that. Where we have another it's called a parametric sonar that can actually do what they call bottom contrasting and characterize the bottom, and it can actually give us a pretty accurate estimate of the silt. So we had done that over that Ocean Springs area, so that's how we knew how much silt was there, and then we were able to correlate that to our edge tech side scan.
Frankly, we're negotiating with a guy for intellectual property to bring that new capability out of hiding. He's a retired
fantastic.
Raytheon engineer, has invented it, and it's a new kind of beamforming sonar that allows us to penetrate, from what we've seen, down to about at least 6 or 7 feet.
Yeah.
And so with a little tiny coffee can size instrument, that's pretty phenomenal.
We've been running that off of a skiff. We haven't actually put it on an autonomous vehicle yet, so that's on our agenda.
As a matter of fact,
I'm curious about
next week about it.
These technologies for being able to do reconnaissance for relict reefs or shell resources.
Yes. Yeah.
Exactly.
Yeah.
That's exactly it.
Sandra, do you have another question? I saw your hand was up at one point.
Yeah, it was just a quick question about post-processing. Do you guys do any post-processing? I assume you clean it up, but my specific question was about analyzing intertidal oysters using drone footage. If we can get the resolution sufficient, have you done anything like that, or you're trying to identify distributions of things, or do you just do the mapping?
Joel probably should answer all of that. The quick answer is we do a lot of post processing to remove noise and give us the imagery that we need. Even though it says research in our title, we're not really doing fundamental research which would allow us to, or we see that it's necessary to categorize the different densities, bottom coverage, different classifications that Tony mentioned earlier, for example. We haven't done that. It's something that we believe with our data can be done, and as part of the work that we're going forward with the Nature Conservancy.
Yeah, so we're not scientists. We're technical geospatial experts. So we rely on scientists to give us the validity of the approach and what we're doing if it screws up the question being asked versus. So we take it all the way to we can tell you, okay, this data is sub 3 centimeter accuracy, and here's the resolution. So so we work with research partners like you guys to actually apply that to a scientific question. But yeah, it's one of the other areas we didn't mention is, we're also getting water column data, and there's a lot you can do with that, but I don't have the expertise to tell you what you can characterize from that, but I've read a lot of interesting stuff. So that's another data set that you're collecting simultaneously, where we haven't done a lot of work or work with people that are looking at that, but we're starting to. And so, yeah, but that takes a pretty good cross section of expertise to make use of that.
Okay, thank you. Yeah.
Steve?
Yeah, I have one more question. How much area can your surface drones cover in a given amount of time, like in a tidal cycle or a day?
The image we showed you earlier of that Bay St. Louis reef took about 4 hours. So the boat travels, ideally surveys at 3 knots. It can go up to 6. We try to keep it at 3. And then it depends on your beam width and water depth, how much overlap it takes. So for the side scan, you get a huge swath. So if you're just doing side scan, it take long. But when you add in the bathymetry, we got to cover a lot more. So we'll typically get, let's say in 4 feet of water, you might get like a 5 to 6 foot beam width.
Okay.
And then it's just we have a calculator as both a philosophical as well as a spreadsheet that kind of gives you a rough idea. Say here's the acreage, here's the average depth, and it'll give you a rough idea of how long it takes.
Mm-hmm. But a typical restoration.
Yeah, most things you can do within a day, typically.
Okay.
Yeah. 2 days, worst case usually.
Well, thank you so much for joining us and sharing this information. We greatly appreciate it, and letting us record your presentation. If you'd like to provide a PDF copy of it, we will post it up in our information. Otherwise, we do have the recording.
We'll do that.
We'll certainly do that.
All right, yeah, go ahead and send to Katie. I think you probably have her email address.
Yes, I'll do that after the presentation for sure.
Very nice. Well, that was certainly super cool tech. I think a lot of us would be really interested in leveraging that. So right now, I think it's a good time to take a little break for everybody. 15-minute break.